Hello my dear students, once again welcome to your online class. Today we will be continuing the chapter chemical bond that we have started in our previous class. So in the last class we had discussed about the electrovalent bond, and in this class we will discuss about the covalent bond, or which is also known as a molecular bond. So starting with what is a covalent bond? The covalent bond is formed by the mutual sharing of an electron. So what is it? So the covalent bond is the one in which the chemical bond is formed by the mutual sharing of an electron, because in this case both of the combining atom, they has a large electron affinity, due to which it cannot completely donate an electron. So thus the atoms which has 5, 6 or 7 electrons in the outermost orbit, they form a covalent bond. So these are usually the non-metals. So the covalent bonds are usually formed between the two non-metals. So coming to the categories of this covalent bond, basically there are three types of covalent bond. They are a single covalent bond, a double covalent bond, and a triple covalent bond. So in a single covalent bond, only a pair of electron is shared between the two of the combining atom, whereas in a double covalent bond, two pairs of electron, that is total 4 electrons are shared between the two combining atom. And in the third category of covalent bond, that is a triple bond, the 3 pairs of electrons are shared between the two of the combining atom. So let us take example of a single covalent bond. For example is a hydrogen. The hydrogen, it has 1 electron in its outermost orbit. So the other hydrogen atom having a similar 1 electron in the outermost orbit comes. So to attain stability, this hydrogen, it must have 2 electrons, but this hydrogen atom, it cannot completely donate an electron. So what do? Both of these hydrogen atoms, they share the pair of electron. So thus we can write the hydrogen has shared one pair of electron. So these 2 electrons belongs to the first hydrogen and as well as the second hydrogen, or we can also write it as H, single bond H. Now coming to the example of double bond, for example is oxygen. So oxygen, it has 6 electron in the outermost orbit. So 1, 2, 3, 4, 5, 6. So in order to gain stability, this oxygen, it requires 2 more electrons. So the other oxygen atom having 6 electrons in the outermost orbit comes closer to it. So in order to gain stability, both of them, they need 2 extra electrons. But here neither of them, they can completely donate an electron. So what do? They share 2 pairs of electron. So finally what happens is, this shared pair of electron makes both of the hydrogen atoms stable. That is, both of them now has 8 electron in the outermost orbit. Thus this hydrogen, this belongs to the first oxygen atom and the other belongs to the second oxygen atom. So in this way both of them, they attain stability. So the oxygen, there is 2 pairs of electrons shared between the 2 oxygen atoms. Thus we write a formula as O2, and here we write it as H2. Now coming to the example of a triple bond, example is nitrogen. The nitrogen, it has 5 electrons in the outermost orbit. So the nitrogen, it has 5, 1, 2, 3, 4 and 5. Similarly the another nitrogen having 5 electrons in the outermost orbit, it comes closer. So in order to attain stability, both of them, they require 3 extra electrons. Since both of them, they cannot donate an electron. So what do? They share the pair of electron, 3 pairs of electrons. So thus in a nitrogen atom, there is a 3 covalent bond. So thus we can write as N2. So this is what a single covalent bond, a double covalent bond and a triple covalent bond means. Just by looking at the formula of hydrogen, oxygen and nitrogen, we simply cannot understand whether it has a double bond, triple bond or a single bond. So in this way you can understand the basic concept of single covalent bond and as well as a double covalent bond or a triple covalent bond. Now coming to the types of covalent compound. usually we have two kinds of covalent compound. One is known as a polar, which means that the atoms forming the covalent compound, they have small charges on them, hence giving a name polar. And the non-polar is the one in which both of the combining atoms, they do not have even a slightly oppositely charged. So as the name is a non-polar covalent compound. So in this, the polar covalent compound is formed when two of the combining atom, they do not have the same electronegativity differences. So that happens when one of the combining atom is more stronger. That means it is capable of attracting the electron more. So in that case, the shared pair of electron goes closer to one of the combining atom. For example, during the formation of HCl. So the chlorine has 7 electrons, 1, 2, 3, 4, 5, 6 and 7, and the hydrogen has 1. So in this case, they share one pair of electrons. So since chlorine is stronger than the hydrogen, that means the chlorine has a larger affinity for electron, or we can also say the chlorine's electronegativity is more than that of hydrogen. So this shared pair of electron, it goes closer to the chlorine, hence giving a slight negative charge to the chlorine, minus del, and a slight positive charge to the hydrogen. So this kind of compound in which the shared pair of electron are at an unequal distance from both of the combining atom, such are known as a polar covalent compound. And non-polar covalent compound occurs when both the combining atoms, they are equally strong. Like example is a hydrogen. While forming a hydrogen molecule, both of the hydrogen, they have the same amount of electronegativity. Hence, the shared pair of electron are at a equal distance from both the combining atom. Hence, there is no oppositely charged developed in both of them. So, such compounds are said to be a non-polar covalent compound. So now, we saw that when the covalent compounds are formed, none of the combining atom, they donate an electron. So thus, the first condition to form the covalent compound is both of the combining atom, they should have a high ionization potential, so that both of them, they may not lose an electron to the other one. And we also saw that when a covalent compound is formed, both of the combining atom, they try to attract electron towards themselves, so that there is no problem in accepting the electron donated by the others. So thus, both of the combining atom, it should have a high electron affinity, means they should have a larger love for the electron, so that when the pair of electrons or more than one pair of electron are shared, they can easily accept them. So basically, they should be to form a covalent compound, the two conditions must be fulfilled. The first one is both of them, they should have a high ionization potential, so that they may not lose an electron. And the second one is both of them, they should have a high electron affinity, so that both of them, they can easily accept the shared pair of electron. So now let us try to understand the formation of some of the covalent compound. We will try with the ammonia, and then we will try with the carbon tetrachloride as well. So during the formation of ammonia, the nitrogen combines with the 3 atoms of hydrogen. So the nitrogen having how many? So the nitrogen, it has 5 electron in the outermost orbit. So I draw 1, 2, 3, 4 and 5. So in order to gain stability, it requires how many more? 3 more electrons in order to become stable. So each of the hydrogen atom along with 1 electron comes closer to the nitrogen. So now what happens? It forms a 3 covalent bond between 3 of the hydrogen atom. So thus all of them, they attain the stable state configuration. Thus after combination, what happens? So this is the before combination. So after combination, what happens is the nitrogen and both the hydrogen, both of them, they attain the stable state configuration. Or thus we can write it as NH3. That is how a molecule of ammonia is formed using the 3 covalent bond between the hydrogen and the nitrogen. So now coming to the next electron dot diagram for the formation of carbon tetrachloride. So we see from the molecular formula that the carbon tetrachloride consists of 1 carbon atom and 4 chlorine atom. So the carbon, it has 4 electron in its outermost orbit. So in order to attain stability, what is required? 4 more electron. So each of the chlorine having 7 electron, 1, 2, 3, 4, 5, 6 and 7. So similarly here 1, 2, 3, 4, 5, 6, 7. Another chlorine comes here 1, 2, 3, 4, 5, 6 and 7. And finally the last one 1, 2, 3, 4, 5, 6 and 7. So what happens? Each of these, they share a pair of electron here, they also say here, this chlorine says here, and finally the last one. So after combination, the carbon, it attains the stable state configuration 1, 2, 3, 4, 5, 6, 7 and 8, and each of the chlorine atom at the 4 corners having 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 and 8. And finally, this is the electron dot diagram after the combination. Thus, we can also write it as CCl4. So, dear students, these are the 2 examples how the covalent bond is formed in ammonia and in the carbon tetrachloride. There are few more examples given in your book which you may practice, and then you may forward it in my WhatsApp number. In our next class, we shall learn some more about the dative bond, or which is also known as a coordinate bond. So till then, you be well prepared with the ionic bond and the covalent bond which we have recently learned in the 2 previous classes.